Tony, you know I always like your work. You're one of our best explorers. But this here is simply over the top, a waste of time. You're hunting a phantom, a complete illusion. If we were a company producing, let's say, sand, great, there's plenty of it down there. But as you may remember, we're looking for oil, so better forget about the south of Libya. The Ghadames Basin hasn't worked too well, so why should Muzak work? The two basins are very similar, as you know. And even if you were to find something, are you going to pay for the 800 kilometers of pipeline yourself? And Kufra? You are kidding me. You may find more oil on the moon than in Kufra. Everybody knows that there's no source rock in Kufra. No, my friend. We will keep staying in the Sirte Basin, a great place. Dozens of big oil fields, close to the coast, plenty of infrastructure, a superb Campanian source rock. Therefore, as of today, I have transferred you to the Sirte group. And please, do me a favor, forget about the south of Libya.
And that's surrounded with water, mountain surrounded with water.
It's quiet in the Sahara. Frighteningly quiet. When the wind rests, you start losing your senses. You can see the desert, yes, touch it, but you cannot hear it. Just you, sand, the barren rock, and nothing else. And whole decades without rain. There are few places on Earth that are more arid than the Sahara. And it's hot, up to 50 degrees centigrade in the shade, if you find shade. And it's large, the world's largest hot desert, 9 million square kilometers, about as large as the United States.
Probably the biggest challenge for exploration today in the southern Libyan basins is that it is still an extremely remote area. It's a long way from facilities. It requires time and effort to get into the field in order to be able to acquire data, to understand the geology. So simply from a logistic point of view, it remains a significant challenge.
Somewhere out here, hidden beneath rock and sand, are oil fields. There are various techniques for finding oil, some more, some less successful. This film concentrates on the most successful of all techniques, understanding the geology behind the oil. Southern Libya is dominated by two sedimentary basins, the Murzuq Basin and the Kufra Basin. Each of these basins is as large as Germany or California. Parts of the basins also extend into northern Niger, Chad and Sudan. The two basins are separated from one another by the Tibesti Mountains. Other basin boundaries are formed by the Jado Plateau, the Hogar, Gargaf Arch, Jebel Dalma, Jebel Iwanat, and the Enedi Mountains. Like many other Saharan basins, the Murzuq and Kufra are Paleozoic zag basins. The first sediments were deposited here already during the late Cambrian. In some areas, even as early as the late Neoproterozoic, the so-called Infracambrian. Since then, several kilometers of Phanerozoic strata have accumulated in the Murzuq and Kufra basins, of which up to 4 kilometers are preserved today. Sandstone and shale, shale and sandstone, hardly any carbonates. Geologists working in southern Libya must consider themselves fortunate because every single stratigraphic rock unit comes to surface somewhere where it can be studied in detail. The strata form concentric rings around the basins, monotonous belts, hundreds of kilometers long. In places, the rocks are eroded away, but then they reappear not far away in another belt. The oldest strata lie at the basin edge, becoming younger progressively towards the basin center. As in every syncline, Jurassic to Cretaceous continental sandstones cover the large central parts of the Murzuq and Kufra basins. The structural tilt towards the basin interior created the typical Saharan cuesta morphology at the basin margins. Ridges made of Paleozoic sandstone and valleys underlain by soft shales. Once you're familiar with the characteristics of the various geological units, you'll hardly need a geological map again. Just follow the outcrop belts and you'll find your way around. Mapping the geology of southern Libya for the first time in the 1920s must have been a real pleasure, and a big adventure too.
Well, the first phase of exploration in Libya, especially in southern Libya, began with the Italians, in other words, during the colonial time, and the pioneer of that time was Desio. Desio divided the Mesozoics from the Paleozoics in the basement, Precambrian, and within the Paleozoics he also did some subdivision. But this, of course, was very preliminary.
Professor Ardito Desio was clearly in love with the Sahara. Between 1927 and 1975, he managed to publish 120 papers on the geology of Libya. Many of the formations he defined at the time are still being used today. Among these, the prominent Tanizuft and Arcarchus formations of the Silurian. After a hiatus associated with the Second World War and Libya's independence, systematic fieldwork in southern Libya resumed in the late 1950s. International oil companies had picked up blocks in the Murzuk Basin. Management sent out some brave young men to go out to the desert and study the rocks. One of these second-generation pioneers was Eberhard Klitsch, working for Deere at the time.
I began to work in Libya in early in '59. It was an extreme challenge for me because except for some field trips, I never was out of Germany before, and found myself in southern Libya, in Deir el-Gussa, and it was extremely interesting within the first weeks to see practically any stratigraphic unit from early or late Precambrian up to tertiary, and including practically any formation which you can imagine. Because I had some idea about paleontology and I had my index fossils of North America with me, I was able to divide all the strata from the Ordovician and Silurian up to the tertiary, to the Paleocene and Eocene. And this within a few square miles, northern Deir el-Gussa and surrounding. So this experience, to find out that you able, even as a young geologist, in an area which is not explored, not really explored, to do geology from scratch, from the base, to also find out that structural developments had changed during the history, or during the time between Cambrian and Tertiary several times.
Klitsch published his results about Deir el-Gussa in the early 1960s, around the same time as the French geologist Jacquet, who in parallel had also studied the eastern Murzuk margin for the Compagnie Française de Pétrole. Even today, these two publications remain the only comprehensive geological descriptions from this area. In the following 4 decades, the eastern Murzuk margin was essentially forgotten. Only a handful of geologists have visited this remote area since then. Today, air-conditioned four-wheel drive vehicles and satellite navigation have lowered the logistical hurdle for fieldwork in the Sahara. It's nearly unthinkable for modern geologists how to navigate in the desert without GPS. Today we plot our GPS track points in real time on high-resolution satellite images or geo-referenced geological maps. Satellite phones transmit your location to any place in the world within seconds. But how was it in the early days of southern Libyan exploration?
Well, the only map we had was the aeronautical chart. And of course, Desio's geological maps. And they had guidelines on his geological maps were not bad. I mean, he subdivided what he called the Nubian or the younger continental strata from the Carboniferous and the Carboniferous from older Paleozoic strata. This was more or less his subdivision, and within these borders it was more or less correct. The aeronautical chart was no help. The position of the oasis was correct, and some of the tracks were correct, but others were not shown, or there were tracks which were not on the map. Except for the aeronautical chart, our base were, at least after a while, were oblique photographs, which were useful because at least you could identify where you were, but you could not identify that on coordinates because it was within, say, 10 or 15 kilometers of what you thought where you were. But it was relatively easy, at least in the eastern Mosaic Basin, to follow the geology. I mean, to go down on the Visayan shale was a very clear topographic help, if you want so. So this was more or less our network. Some geology, some old tracks. There was a track to Kufra from Seba via Wal-Kebir and via Namus to Kufra. At least in northern Libya, not so much in southern Libya, there were plenty of seismic lines and lines of gravity parties and whatnot. So one of my jobs was several times to bring people back which got lost, following the wrong tracks, or it was always people from our seismic crew, and normally it was experienced people which got lost because they were careless. They went without water, sometimes without spare part, without spare tire and whatnot, even without jacket also. One we had to look for once at 4 days until we found him. He was almost dead. Because in winter it was minus 5-6 degrees and he had no jacket, nothing to drink, nothing to eat. It was tough. Well, we brought him back, a survey engineer from Bavaria. But he was not the only one, and several got lost and never came back. Not in our teams, but there are several people got lost. One truck got lost west of Jebel Harouch. He went south instead of north. He had plenty of water, but not enough fuel or diesel to return to the main road after he found out that he was wrong. He was found 50 years later, dead, war verhungert. And several people lost their head by leaving a helicopter in a sand area, and the helicopter turned to one side, and this was the end of the head. So it was, I will not call it dangerous because this was rare cases. There was plenty of geologists on their way. But it was adventurous in a way, yeah.
Comparing the southern Libyan basins to other regions of the world, the story initially may appear very simple. Sometime around the dawn of the Paleozoic, two bowl-shaped basins begin to form. They keep deepening until they reach their maximum depth today. The newly created accommodation space gets continuously infilled by sediment dumped into the basin. Rock layer after rock layer is formed until the basin is eventually full. A simple and easy to understand basin history model. But unfortunately, completely wrong. You'd find more oil using the darts technique than employing this continuous sag basin model. So, how did the basins really evolve? When and where were the hydrocarbons generated? And for how long were the source kitchens active? What were the key migration routes? Which rocks offered the hydrocarbons a new home? And most importantly, are the hydrocarbons still there? Continents have been drifting over the surface of our planet for most of the past 4.5 billion years. Lonely pieces of land surrounded by crashing waves on all sides. During rare occasions in Earth history, however, these cratonic blocks were called to come together. As if a giant magnet was suddenly switched on, the landmass's paths suddenly converged. It's during such a continental reunion where our geological story of southern Libya begins. Numerous continents, cratonic fragments and island arcs were on the move. Eventually they collided during the so-called Pan-African orogeny to give birth to the legendary southern megacontinent of Gondwana. Gondwana was the united South America, Africa, India, Australia and Antarctica. Two large cratonic blocks dominated the area at the time that today is North Africa. The West African Craton and the East Saharan Craton. When these two cratons crashed into each other, a large Pan-African collisional zone developed between them, the Trans-Saharan Megabelt. Some authors say the Western Murzuk got caught up in this collision, while the Eastern Murzuk laid on the stable East Saharan Craton. And also the present-day Kufra Basin was rather safely positioned on this block. East of Kufra, however, another war zone erupted. Series of island arcs were thrown against the East Saharan Craton and were accreted. The resulting East African orogen is more than 2,000 kilometers wide and extends over Egypt and the Arabian Peninsula. Never again since these times have continents collided so close to southern Libya. The rocks preserved from this phase come from the deep. Formed several kilometers beneath the Earth's surface, they speak of high temperatures and enormous pressures. Banded and strongly recrystallized metamorphic rocks, plutonic granites. The crystalline basement of southern Libya. A basement which is of Neo-Proterozoic age in the Pan-African mobile belts, but which can be much older on the cratons. The Precambrian basement comes to surface in several places around the Murzuk and Kufra basins. A good area to study the Pan-African action of the region is the Hogar Massif in neighbouring Algeria, which is part of the Pan-African Trans-Saharan Megabelt. Here, the structural fabric of the central North African basement is revealed. A fabric that also extends into the subsurface of southern Libya and forms the basis for much of the later structuration. The Hogar's Precambrian basement is disrupted by deep-reaching vertical shear zones that generally trend in north-south directions. These shear zones often represent the former terrain boundaries of the small continental fragments involved in the Pan-African collision. Wounds in the Saharan body which never healed again until today.
Prior to the Cambrian and Precambrian, the structural lineations were mostly broad and north-south. So at that time, most of the sedimentary basins were not created.
Ever since, every little pushing and tilting has caused southern Libya and Algeria pain along these reactivated old zones of weakness. Depending on stress directions, the land was pushed up or down, intraplate transpression and transtension.
So you can see that so many tectonics had been really involved within the basin itself. There are structure had been rejuvenated from time to time, up and down. There are faults had been disappeared, even though they were there, because they went up and then they went down. So seismically you cannot see that.
To reach this remote part of the Sahara at all, the stress propagates over thousands of kilometers from the Phanerozoic collisional zones far across the stable Saharan platform. As in every modern mountain belt, there were also sediments deposited during the Pan-African orogeny. But none of them survived. They were either cooked and squeezed or simply stripped off again. The Precambrian crystalline basement forms the substrate of southern Libya. Now the stage is set for 540 million years of Saharan geology. Let the sedimentary action begin. Sediments need space to be deposited. And towards the end of the Pan-African orogeny, right into the early Cambrian, northern Gondwana created some space. Gondwana and the Pannotia megacontinent came under tensional and strike-slip stress. Laurentia, Baltica and Siberia separated from Gondwana. The Iapetus, the Proto-Atlantic, opened up. East Gondwana pushed heavily into the East African Antarctica origin and triggered off escape tectonic movements on the Arabian Peninsula and in Egypt. And to make things worse, the newly formed Pan-African origins gradually began to collapse. Destructive times all across Gondwana. Half-grabens and pull-apart basins opened up locally and were infilled with sands and muds. Away from the silicoclastically contaminated zones, vast stromatolite colonies developed. In oxygen-deprived deeper parts of the shelf, organic matter was deposited and preserved. These infracambrian organic-rich shales and carbonates have sourced large oil fields in the Omani salt basins. And also to the west of Libya, the infracambrian is a working play. Gas shows in the Mauritanian Touadéni basin speak a clear language. In Libya, the infracambrian play and its potential is still extremely poorly understood.
Specifically for the infracambrian in southern Libya, then we rely at this point in time very largely on these very sparse seismic data sets we have, but it's very clear that under the Kufra Basin, for example, there is a remnant half-graben, in fact several remnant half-grabens, which almost certainly contain infracambrian sediments. And we are able to make correlations on the seismic data between the sequences we see in the Kufra Basin and, for example, the sequences we see in Oman, where there is a very prolific infracambrian Neoproterozoic petroleum system. So there may well be a direct analogue between those two.
Nobody knows what sort of sediments are hiding in these Kufra half-grabens. There are no wells. Is it just boring sand? Or is there any chance for more interesting stuff? For example, an Oman-type organic-rich carbonate facies. At the moment, we simply don't know. Although there is something at the eastern Kufra margin that fuels our hopes.
As far as we have seen in the field that there are some marble infracambrian, that means metamorphosed carbonates.
Marbles, sitting directly on basement. Maybe of infracambrian age, but just maybe. There are structures in these marbles that look not too different from stromatolitic bedding. Or is it all just metamorphic foliation? And also at the eastern edge of the Morzuk Basin there are strata of Infracambrian age. The Murizidae Formation, a purely siliciclastic series made of sands, silts and muds. But in an area with potential half-grabens, it's highly unlikely that we're dealing with layer cake stratigraphy. Strata may suddenly appear and after a few kilometers abruptly end again. In concession NC 101, the A-well found some suspicious Infracambrian deposits. Dark grey to black siltstone, partly with calcite. Oman surely cannot be too far away.
We've not identified at this point in time significant basins underneath the Morzuk Basin that are Infracambrian basins, but there's no reason why these shouldn't exist.
At the end of their lives, the Infracambrian grabens in Kufra became inverted. This is what the seismic tells us. It's therefore fair to assume that Infracambrian sediments once might have covered large parts of southern Libya, but quickly afterwards were eroded again. The Infracambrian rocks we see today are the erosional relics of that time.